Hi, I am Prajwal. Today, on behalf of my team, I'll be presenting our time series analysis on renewable electricity production in Australia. We have used monthly data from 2010 to 2025 and applied forecasting models to predict future trends in clean energy. Here, we are using monthly renewable electricity production data for Australia sourced from the International Energy Agency. The data spans from January 2010 to February 2025 and includes all major renewable sources like solar, wind, hydro, geothermal, and others, measured in gigawatt hours. Our research question is, how has renewable electricity production evolved over the last 15 years and what can we expect in the next 10 months? This question is important because renewable energy is central to sustainability goals. Understanding these trends can guide policy decisions and investments as Australia moves towards a low carbon energy future. Now, if we look at the line chart, there is a clear upward trend across the years with growth picking up sharply around 2018. We also notice seasonality. The production tend to rise and fall in regular yearly cycle, likely due to weather patterns like sunlight or rainfall. The variance stays stable. The fluctuations grow along with the level but remain proportionate, which is good for modeling. We saw autocorrelation where current values are influenced by past months, suggesting memory in the system. Finally, there are a couple of noticeable change points, especially in 2018 and during 2020 to 2022, probably due to new policies or renewable energy projects. To understand the nature of the time series, we started the ACF and PACF plots, which showed a slow decay and several significant lags, both signs of non-stationarity. The ADF test confirmed this with a p-value of 0.2407, that is above 0.05, indicating the time series is non-stationary due to trend and seasonality. We also checked for normality. The QQ plot and the Shapiro-Wilk test showed deviations from normality with a very low p-value. Finally, the box plot helped us choose an appropriate lambda for transformation, improving model performance. These tests guided our pre-processing steps for fitting the ARIMA models. We began our model specification by applying seasonal differencing d is equal to 1 after confirming non-stationarity and visible seasonality in the time series. Starting with the baseline SARIMA 000-01012 model, we analyzed residuals to guide further refinement. Together, we identified SARIMA 013-21212 as a suitable pivot model based on residual diagnostics and significance of coefficients. This model was then used collaboratively as the base of EACF and ARMA subsets analysis to explore and validate optimal ARMA order combinations. We tested several SARIMA models by adjusting AR, MA, and seasonal terms to capture both the short-term dependencies and yearly seasonality. To select model parameters, we relied on ACF and PCF plots to identify AR and MA lags, EACF and BIC tables to narrow down model combinations, seasonal differencing and regular differencing to address the trend seasonality, and evaluated models using error metrics like AIC, RMSE, and MAPE. Two models stood out: SARIMA 013-11212, SARIMA 313-11212. Both models performed well, but SARIMA 313-11212 had slightly lower RMSE and MAPE, better behaved residuals, and passed all diagnostic checks, making it our final model. We validated this choice using residual analysis plots. The residuals showed no trends and looked randomly scattered in the time plot. The histogram and QQ plot showed the residuals were roughly normal. The ACF and PACF of residual had no significant spikes, confirming no autocorrelation. And the Young box text p-values were also above 0.05, indicating a good model fit. Based on all these checks, we finalized this model for forecasting. Our final forecast projects a steady increase in renewable electricity production over the next 10 months, with clear seasonal patterns continuing. This outlook reflects strong momentum in Australia's transition towards the clean energy, a promising sign for meeting sustainability goals. Thanks for listening. This project helps us understand how time series analysis can support real-world energy planning. Happy to take any questions. Thank you again.